Today's lesson, we're looking at differentiating exponential functions, and the function we're actually looking at is something called e to the power of x. Now, you don't know what e is yet, but you have seen graphs such as in our first topic, functions. You saw the graph of y equals 2 to the power of x. It's called an exponential function. Now, in the calculus topic a bit earlier, you learned how to differentiate. Now, we don't have a formula for differentiating y equals 2 to the power of x. It is a little bit complicated, all right? So that's not part of the syllabus. But I'll just show you here. So if I just put in here that y equals d by dx, which is the derivative of 2 to the power of x, don't the functions look very similar? So the red function is 2 to the power of x, and the blue function is the derivative of 2 to the power of x. What we have done, but in one of the topics where we had the original function, we sketched the gradient function. So the blue one is the gradient function. It's almost identical. You know how you would say here, and you can see where my cursor is, wouldn't you say the gradient is, one sec, positive? Would you say this is a positive gradient, but small, gradient gets steeper, positive gradient, gradient gets steeper, all right? So the red one is the original function, 2 to the power of x. The blue one is the gradient function. Y is, because it's telling me that the y value has to be the derivative of 2 to the power of x. All right, so they're fairly close, right? Just keep that in mind. Now I'm going to change it. 3 to the power of x, and the derivative, of 3 to the power of x. It's almost sitting on top. Was the other one below? I'm actually going to put the others again. So y equals 2 to the power of x, because I can shut it on and off. There's 2 to the power of x there. And then I'll show the other one as well. D by dx of 2 to the power of x. Now, let me just turn these ones off. Okay, so this is what we started with. 2 to the power of x is green. The derivative of 2 to the power of x is purple, so it's a little bit lower. Do you think its y values are a bit lower? Like if I look at the green curve, when x is 2, what's y? And if I look at the purple curve, when x is 2, y is a bit under 3. So it's below it, okay? Now, if I put this 3 to the power of x curve up, right? Look where it's the red one, but look where the derivative for 3 to the power of x sits. Slightly above it. Can you see it? The blue one is above the red one. So somewhere between, so I'm going to get rid of the derivatives. So the green one is 2 to the power of x, and the red one is 3 to the power of x. And the derivative for the green one was below the curve, and the derivative for the red one is above the curve. There is a number between 2 and 3. Do you think now that there is going to be a number between 2 and 3 where the derivative sits exactly on top of the curve? Do you get what I'm trying to show you here? So if I look at the green curve, its derivative is below it. So the derivative for 2 to the power of x is just below it. The red curve is 3 to the power of x. Its derivative function is the blue one. It's sitting above it. There is one number where the derivative function sits exactly on top of the function. Okay? And that function is e to the x. Now, e is called Euler's number. Look, watching? There's e to the x. And in blue, why can't I get it? I lost it. Oh, get rid of that one. So, oops. E to the x is in red. That e to the x is the red one. And the derivative is sitting straight on top of it. It is. They're both there. So that means that the derivative of e to the x is e to the x. It's the same function. They're identical. Okay? So from our investigation, we know that, from our investigation in Desmos, we know that if y equals e to the x, then its derivative, what's the other way I can write its derivative? I can write then y dash is e to the x, or I could write if y is e to the x, then, do you remember this? dy dx is e to the x. Or I could write it as if the function of x is e to the x, then how would I write the next one? Yep, good. So this is all the notation. F dashed x is e to the x, or I could even write it another way. Or, so with these three ways, we write if y is e to the x, then y dash is e to the x, or dy dx is e to the x. Or we could have said function of x equals e to the x, f dashed x is e to the x. Or if you're not saying y equals that, or function of x equals that, the other way to do it is if I say differentiate e to the x, I would say d by dx of e to the x is e to the x. So that's four ways in which a derivative, like you can be instructed to differentiate. Four types of notation that you can use. See, sometimes in papers you'll see it just says differentiate this. Now, if it just says differentiate that, you can define and say if y equals that, then y dashed is that. Or you could say if y is e to the x, then dy dx is that. Or you could even do that. Or you could just say the derivative of, so d by dx is the derivative of this with respect to x, is e to the x. That's what I put in on Desmos, okay? So basically, we can just box it, whatever. The derivative of e to the x is e to the x. So what is e? Okay, you can get your calculator out. E is called Euler's number. And on your calculator, you can enter it as e to the power of 1. That's how you can enter it on your calc. And you get 2.7 what? 18, etc. It's just like pi. You know, 3.1415, whatever. We've got e now. 2.71828, etc. So how do you enter it on your calculator? You do e to the power of 1 equals, and you should be able to get it. It may be sitting in orange on top of another key. Is it? Sitting on top of the LN button? The reason it's sitting on top of the LN button, because LN means log to the base e, and e to the x are inverse functions. But we'll look at that next lesson, or the lesson after. So that is why, because e is 2.718, when I did the derivative of y equals 2 to the x, the derivative was below the curve. When I did the derivative of y equals 3 to the x, my derivative was above. Doesn't 2.718 lie between 2 and 3? And it's actually closer to 3, which is why that is the magic number there, where the derivative is exactly equal to the function. All right? So E is Euler's number. So I could ask you just to do a few calculations with E now. So let's calculate the following. So let's just calculate the following using your calculator. Of course, in some questions, you'll be required to calculate E as part of a question. So you've already worked out E. Can you try E squared? Do E to the power of -1, maybe 1 over E squared. And let's try 2e to the -1. Off you go. Try those on your calculator. What you do, whenever you're coming up, if maybe as part of an answer you may be required to enter e into your calculator, you know that e is almost 3. So e squared would be a bit less than 3 squared. Now 3 squared is 9. We're expecting the answer to be maybe about 8-ish. What do you get for e squared? 7.3. I'll just go with that. All right, e to the -1, doesn't that mean 1 over e? So you're expecting roughly about 1/3, roughly. It's 1 over 2.7, whatever it is. So can you do either e to the power of -1, you can probably do that, or 1 over e, whichever one you like. What do you get? I'm thinking about a third, about 0.2 something, 0.3 something. Etc. 0.3678. All right. 1 over e squared, that should be approximately 1 over 9-ish, roughly, about 0.1-ish. Anyone? I want you all to do it on your calc. You have to know how to use your calc for it. So this one is really 2 over e, because e to the negative 1 is 1 over. So that's about 2/3. So I'd be expecting about 0.7-ish. What are you getting? Etc. So it makes sense. So whenever you're doing any calculations with e, if you sit there and say, right, e is about 3, it's a bit under 3. So I'm expecting, like I said, e squared to be a bit less than 9. I'm expecting 1 over e to be about 1/3. We know 1/3 is 0.333 recurring. All right? 1 over e squared would be about whatever 1/9 is approximately. All right? Okay. The function of x equals x cubed plus 3x minus e to the x. Find the following. F dash x. Okay, so it's really good that you did some, hopefully, derivative differentiation revision on the weekend or during the week, because we're now differentiating that. So if the function of x equals x cubed plus 3x minus e to the x, find f dash x. How do you differentiate x cubed? 3x squared plus 3 minus, how do you differentiate e to the x? E to the x. Okay. I might say to you, find, what if I say find f dash 1? So I've done function f dash x. What's f dash 1? I replace the x with a, anyone? 1. So it's 3 times 1 squared plus 3 minus e to the 1. And what do you get? Don't use your calculator. Oh, also, I need an exact value. I want an exact value. So do not put e into your calculator unless they are asking so many decimal places or significant figures. So 3 times 1 is 3 plus 3, that's 6 minus, anyone? No, you leave it as e, as an exact value. So f dash 1 is 6 minus e. So often you'll have to leave your answer as an exact value. Now, just a few more. All right, e1, number 2. So differentiate e to the 3x. Oh, no, you can't do that. 3e to the x. So if y equals 3e to the x, then dy dx is, because the 3 is just a constant. So it's just 3 times whatever the derivative of e to the x is, which is, yeah. So that's 7. So let's say I asked you to differentiate, for example, if y is 3x squared, how would you have done this one? So if y equals 3x squared, how would you have done this? 3 times the derivative, 2x, which is 6x. So we're doing the same here. If y equals 3 times e to the power of x, the derivative is just going to be 3 times the derivative of e to the x, which is e to the x. I'll do some more. Actually, I'll write a rule out for that one. So that if y equals e to the power of x, then dy dx is also e to the power of x. Now, if y equals k times e to the x, where k is a constant, dy dx is just the constant times e to the x. It's just the same thing. Yes? All right, because when we were doing all those, the ones like 3x squared and stuff like that. All right, so let's just differentiate a few more. Differentiate the following. I'm just making them up as I go. All right, y equals negative 2e to the x. Y dash is. Another example. Y equals e to the x. All right. Derivative of this is just negative 2 times the derivative of e to the x, which is e to the x, which is negative 2 e to the x. Now the next one, What's the derivative of e to the x? It's just e to the x minus 2 e to the x, but be careful. No. E is just a number. So if I had, wait, plus e plus 7x, let's add to it, minus 5. All right, add to the question. So girls, if I differentiate 7x, what do I get? If I differentiate negative 5, what do I get? E is the number 2.718, etc. If I differentiate that, I get 0, just like the constant. So E is a constant, just like negative 5. So if you differentiate a constant, you get 0. So plus 0, plus 7, minus 0. So that's just showing that if you differentiate E, you get 0. It's just like you're differentiating negative 5 or 5. If you differentiate 7x, you get 7. So what do I get here? E to the x minus 2 e to the x plus 7. All right, I'll do a few more. Let's differentiate, I don't know, 5x cubed minus 4x plus 3 over 2 e to the x minus e squared. Differentiate. Trying to trick you. I'm trying to trick you. What we learned earlier was that if y equals x to some power, x to the power of n, then dy dx or y dash is bring the n to the front, write the x out, drop the power of n by 1. Then you also saw a rule like the following. If y equals k times x to the n, which is a constant times x to the n, then y dash will be that constant times the derivative of the x to the n, which is bring the n down, write the x out, drop the power by 1. Okay? Now, it's different with the e to the x rule. The rule is just if y, see this x is not on the base. X is an exponent or a power. So it doesn't follow these rules of differentiation that we looked at earlier in the year. Okay? So the rules just are if y equals e to the x, then the derivative is e to the x. And if y is a constant times e to the x, then the derivative will be the constant times the derivative of e to the x, which is just the constant, times e to the x, okay? Whereas here, you'll often see a change of value because you're multiplying the k by the power that's brought down here. All right, we'll just keep going. Okay, all right. So with this one, what does this become? First one, if y is 5x cubed, because you go 5 times 3x squared, don't you? Minus 4 plus, that is a constant in front of the e to the x. So it's 3 over 2 times e to the x minus, no, that's a constant. E squared is, on your calculator, there's no x in it. E squared is a constant. Look. Oh. Is a number. It's 2.718, whatever it is, squared, which is approximately 7.8. So that's just minus a constant. That is a number. See, e to the power of x is not a constant. It's got a function of x in it. But if you think of e, every time you see e, just think, oh, that's approximately 3. Just like we do with pi. When you see pi, you say, yeah, that's about 3. Do the same for here. That's about 3. So it's minus 3 squared. So it's really just like it was minus 9 here, approximately. That's a constant. Now, what about 3 times e? That's just a constant. So our answer is 15x squared minus 4 plus 3 over 2 e to the power of x. How are you going to differentiate this? Before you differentiate it, you're going to have to do something here. Just doing a bit of revision here. Yeah, you can't differentiate that with the x squared on the bottom. Well, you can if you want to use quotient rule, but there's not two functions of x. You'd write it as 5x to the negative 2 minus a half. So this is still what y is. I have not differentiated yet. You would never use the quotient rule here because 5, there's no function on top. There's only a function on the bottom, so you just move it up and you write it as a negative power. All right, let's differentiate it. dy dx equals, off we go, 5 times negative 2x. So we keep the constant. We bring the power down, we write it out, we drop the power by 1. Yeah, don't put negative 1. You go, this is what you say, you go negative 2 minus 1, negative 3, minus a half is the constant, times what? Bring the 4 to the front, 4x cubed, and that is a constant. It's just a number. So you get plus 0. So if you want to simplify that, what you get? Negative 10x to the negative 3 minus, yep, a half of 4 is 2x cubed. You can make it look nice. Negative 10 over, you should really make it look the way that the question was written. There were no negative powers in the question. So what are you going to do with this x to the negative 3? Put it on the denominator, and that's your derivative of that. I know I took 5 lines to do it, but okay. In gradients and equations of tangents and normals. So here is an example. Find the equation of the tangent to the curve y equals 3e to the power of x at the point 0. So just going to find equations of tangents and normals to curves and their gradients, all right? So here is an example. Find the equation of the tangent to that curve at the point 0, 3. How do you do this? Do you remember how to do that? Not yet. So you've got to find the gradient first. So you go y equals 3 times e to the power of x. Don't we do dy dx equals, differentiate that for me, 3 times e to the x, which is 3 to the x. So that's my gradient function. Now, you know, 3e to the x looks like this. That's what it looks like. And it's when x is 0, y is 3, it looks like this. You know, its gradient changes all the time. So I want the gradient, the equation of the tangent to the curve at the point 0, 3. So I want this equation. So I need something. I need to know the gradient and the point. So what's the gradient? That's my gradient function. What do I do next? I say when x is 0, dy dx is 3 times e to the 0. Do you remember this? Which is 3 times 1, which is 3. Now what do I do? So I'm trying to find the equation of the tangent. I know the gradient of the tangent. So m is 3, my gradient's 3, and my point is 0, 3. So now I use my point gradient formula. So using the point gradient formula, so whenever you're asked for equation of tangent, equation of normal, you want to find your gradient by differentiating and substituting in your x value, and then you've got your point, and then you use your point gradient formula. So do you remember the point gradient formula? y1 equals m bracket x minus x1. Yeah? So it's y minus, good, equals 3 bracket x minus 0. And you can put your x1, y1 there. And then you've just got y minus 3 equals 3x minus 0. So it's just y equals 3x plus 3. Makes sense. The gradient of the line's 3. You know, we could have just done y equals mx plus b. The gradient's 3 and the y-intercept's b. Or we could have just gone, the gradient's 3. This is a straight line. I know that the y-intercept is 3. I can see it there. So it's just 3x plus 3. It doesn't matter. There aren't going to be many that you can do that way. The equation of the normal to the curve y equals e to the x at the point where x equals 5. Here we go, girls. Find the equation of the normal to the curve y equals e to the power of x at the point where x equals 5. Now, I'll give you a sketch of what we're actually doing. E to the x looks like this. Remember e, it looks like y equals 2 to the x or 3 to the x. It's just not as steep as the 3, and it's a bit steeper than the 2 because e lies between 2 and 3. Let's say that this is 5 here. That, in pink, is the tangent, yes or no? And do you know what the normal is? It's at 90 degrees going the other way. Yeah, that's right. And that there is your normal. That's right. So, I don't want so what we just did in the question above was the equation of the tangent. Now we're doing the equation of the normal. So, how do we do that? First, we almost know the point. We got 5 something. We're going to have to work out what the point is. So we'll do that in a sec. So the curve is y equals e to the x. So I've got y equals e to the x. What do I do first? Differentiate. Dy dx is also e to the x. So now what do? I need the gradient. So that's the gradient function. This is my gradient function. This gives me the gradient at every point on the curve. All I've got to do is substitute in the x value that I'm talking about. So now I go, when x is 5, my gradient is what? E to the 5. So my gradient is e to the power of 5. What's my point? So here's my function, y equals e to the x. When x is 5, what's y? I know it's a bit weird. E to the 5. It's the same, the gradient and the... I know, it's a bit... Yeah. So what's your point? Its x value is 5. When x is 5, what's y? I know, it's a bit weird. Okay. So the gradient, the reason that the gradient is the same as the y value is because the derivative is e to the x. It's the same as the function. Because the original function is e to the x, the derivative is e to the x. So when you substitute x is 5 into the original function, it gives you the same value as when you substitute x is 5 into the derivative because they're the same function.
So that will happen all the time?
Only for e to the x, but not for 2e to the x. That'll be different.
Yeah.
Oh, actually, yes, no, it will happen for that. But not from tomorrow when we do e to the ax. We'll be doing other, oh no, Thursday. All right, wait. So, equation of, oh, wait, I've made a mistake. What do I have to do? That's the gradient of the tangent. So that's the gradient of the tangent. So the gradient of the normal is what? Sorry, that's really messy. Gradient of the tangent is e to the 5. What's the gradient of the normal? -1 over e to the 5. Sorry. So that says gradient of tangent. So let's do our point gradient formula. Y minus y1 equals m bracket x minus x1. Y minus... That's my m, that's my x1, y1. Y minus what? E to the 5 equals -1 over e to the 5, x minus 5. x1, y1. Gradient of tangent e to the 5, gradient of normal -1 over e to the 5. All right, I've got to rearrange it. See this e to the 5, it's on the denominator. Put it, look, you can expand if you want, but I would put it into general form. What am I going to do with this e to the 5? Take it. Look, I've got two choices here. I could expand. Look, watch. I could expand. Let me expand it and I'll show you what I get. What do you get when you expand? Negative x over e to the 5 plus, I'm expanding. I'll expand, that's one way to do it. What do you get when you expand? Plus, come on, 5 over e to the 5.